So we got chapter 10, Cisco. So talk about, we should be able to do the following. We should be able to here 6, we'll have to do that on packet tracer, and we can work on those over the weekend. You know, at least experiment. We'll look at a little bit of that. The objectives, you can read through those. What we're working on right now, 4, and then we'll have to be able to troubleshoot, and we'll talk a little bit about the theory on this and work on that in packet tracer. Key things you're going to give an address for. Big deal nowadays. Think about it. Do you ever have to stop and put an IP address in your phone? Laptop? I mean, you know, this is a big deal. How we do this is a big deal. And can you see why they put a lot of work into version 6 on how to handle this? Because in version 6, the router itself can give that address, which is going to be important. The Internet of Everything, you want to be able to have your devices, whatever they are, whether they're in your car or whether they're in your phone, on you, you know, your refrigerator, I don't know. We want these devices to almost seamlessly connect to a network. Okay? So we can force it to have a particular address. We can automatically allocate an address. Okay? Or dynamic. Which one do we use the most? At least in our limited knowledge at this point. The dynamic. Yeah, we give a address, we lease it for a certain period of time, and then we can get it back. Okay? And it's important to have just a general idea of how the process works. So, right? Discover. This is a broadcast. Do we have any IP addresses at this point? No, so what do we have to use in order to get it to broadcast? Yeah, MAC addresses. We have MACs that we can send out. Okay, so then an offer, that can be a unicast coming back, because we don't have an IP, but how can they send a unicast? They have our what? MAC address, and we're all on the same network. Very good. Request, they acknowledge. Any questions there? I'm going to keep rolling so you have time to get back to the lab. Any questions? Questions? All right. Do it later on. You know, this is a situation to, do we memorize this? No. Can we look it up? Yes. If you have the time, it's good to go through and kind of understand how these packets look. Is this production data or management data? This packet is for management, right? We're trying to get it, we're using a protocol to get an IP address to a client. Okay? So you should always be able to decide that, but it's traffic on your network. Digging through these can help us understand a little better on how it works. Okay? We're not going to go, you can go back through the curriculum, look at all those. All right? So this is what you're doing right now. So we're setting up, in this case, they're excluding some addresses. Now I don't know if they specifically state here, but you exclude the addresses you don't want to dish out, okay, for whatever reason. They might be default gateways, or they might be internal servers. Thank you. Okay? Then you create a pool. Does the pool have to be LAN pool 1? No, it could be whatchamacallit pool, or whatever you want to name it. Okay? So it's up to you when you're designing or working within a network, how you manage the names. That's up to you. So this is the network we're going to take the address out of, and we will not taking any of those addresses that are excluded. We have to have a default gateway. We need to have DNS, and you can also give an optional domain name. All right. And it should work. And you can do some show commands to look at that, right? The helper is if the server is where? On another network. So we can just point to it. It's on the other, maybe the other side of the router, your server. So you got to use a helper. This would not be so unusual, right? You know, you could have a network. You could have a network, and on a separate VLAN could be all the servers. Get it? So you would need a helper to push through and find that DHCP server. Everybody's clear, the DHCP server doesn't have to be in the routing device. Right? I mean, it could be in a standalone server. It could be in a virtual box, and one part of that box is a DHCP server. Have you guys designed DHCP servers yet in Microsoft side of things? Not yet. Okay. You can look at it and say, well, it's probably not real hard, but you could do that. And it doesn't have to be Microsoft. You can create a DHCP server in a Linux box or whatever. You just indicate that it's a server. And then you have to obviously give out addresses. So you can have your router get an address. Does this happen at your house? Yes. Right? If you have that little router connected to your house, you got the cable modem or a DSL connection, somehow or another you're getting an IP address from your ISP. And you can do that right here. Okay? We'll show that here. Actually do that. Does that make sense? So your router can automatically get an address. Troubleshooting, they give some things to do here. Good things to, won't go through all the troubleshooting items, but you can actually access lists and capture some packets if you want to see where the packets are going. Yeah, there's another example of access list you might not have ever known about, right? There's a lot of things you can do in terms of creating an access list and using that access list to see packets. If you do a debug all on a router, have you done that yet? It's crazy. I mean, you see everything, and it's so hard to decipher what's really of value. So it's much better you could go a debug IP packets, and you still see a lot of information, but you see all the packets. And you could break one of them packets down in terms of, okay, that's a DHCP packet, and what's in there? Is it working? You know, where are things going wrong? Let's run through these slides once, okay? And then if we need to, next week, we can go back and look at it more specifically. Okay, if you have, in fact, next week we can touch upon 2 or 3 different IP6 things, make sure we have it down, or at least have a pretty good idea. You good? You see what I'm saying? I worry about you focusing so much on IP6 that you don't learn the general concept, because there's a lot to learn now. You're 6 and 4, 6 and 4. But you'll be okay. If you understand the basics of networking, the addressing part's going to change. It's actually going to become easier down the road. It will become easier. So, what do we got going on here? What are they saying? Right here in the slide, we're talking about SLAAC is a method in which a device can obtain an IP6 global unicast address without the services of a DHCP server. In your own words, what's happening? It's not much different than what we're doing with the router And DHCP version 4, the router is just going to help do what? Get you an address, right? A local link address. Now just don't worry about all the technical parts of this. Just think about it for a second. What does this workstation need to know in order to be on the network? Just don't worry about DNS or anything right now. Just the basic things it needs to know in order to connect to the network. What does it need? It needs a logical address. Okay, that seems overly simple. Does this router know what network it is? Here's a big hint. Yeah, it knows. Somebody configured that. Otherwise, we wouldn't be anywhere. You can't connect unless. So somebody gave that router the network, right? Because a router, each port is a network. So it knows what the network is. The only thing it doesn't know are all the what? Host addresses, right? And so, does this, what two ways can we do it? What two ways will it work here to do this? We can either use what that's unique to the device. Great, we could use the MAC address. Or, just pick a random number, okay? You say, well, pick a random number, it's crazy. Well, what it's going to do is, once it gets an address, what's it going to check? Are there any duplicates? Okay, so it's going to go back and check if there are duplicates anyway. So in just plain old English, we can use the MAC address, right? We can get the network from over here, 64 bits for that. And then we can take the 48 bits from the, let's just say we're going to use the MAC address. We can take those 48 bits and then use that method. You can go back and look it up. I'd have to go back and look at it. But no, it takes those 40 bits and adds some bits in there. And you get a unique address for the device. It's really a great way to do it. So, right? A request, and then the router answers. All right, let's just run. Router does a solicit. Actually, the PC does a solicitation, if I can pronounce it. The router sends back an advertisement. Create a global unicast address, and then check for duplication. See how it works? Nods aren't always necessarily the true answer, but at least we have a concept, right? So SLACC only, Slack only, okay, or that and the DHCP server or some other services that you're going to grab from there, or you can say we only want to do it with DHCP. We want to give out the addressing information. We want to work like version 4. So we have those three options, right? There you can set the flags in order to indicate which of those three options you want to do. If these are both set to 0, it's the default, right? I think I have that right, isn't that? RA message contains all the addressing information I need. There is no other information available from a DHCP server. It has what we need. Would you ever connect devices and not give them a DNS address? Well, think about it for a little bit. Does every computer in the world need to go to the internet? Is that a better question? How about for the centrifuges, the network running those in Iran? Did they have any connection out? No. They didn't have the last thing they want to do is connect the internet. or you have some highly secret, I mean, just think there are literally probably, I don't know, thousands of examples where devices, you don't want them going to the internet. So would you even need DNS? No, don't even give them DNS. Do you see my point? So there's a lot of people say, well, geez, who would ever want no DNS? Well, there's a lot of situations where maybe you would. Yeah, you can go all kinds of examples. So we good there? We're going to move on. So you got these up. I'm not sure you want to memorize them today, but you need to understand that there's multiple options and how you would set it up. And then someday, like over the weekend when you have to do it in Packet Tracer, you might have to re-look it up and make sure you get it right. You get it? And then in a year from now, and you happen to get in an IP6 environment, you'll have to look up exactly what the situation is, but at least you'll know, well, I know I got some options, okay, in order to assign those addresses. So this is the first one, right? The first option. Are we good? They're both zeros. And that's the default. See, we got a server, we got a router, and one. Shows that operation. We go here, and it tells us we have to contact the server, and so then it could be this environment. Get it? So you're really doing both. You're getting your addressing over here, and then over here you're picking up other things, like DNS, or trying to make it simple. And then they go through some of the configurations, okay? Help you in terms of trying to do it in Packet Tracer for version 6. And if you get stuck, don't spend hours, but spend a decent amount of time seeing if you can get it to actually get addresses and work, okay? And I haven't done it yet in Packet Tracer, but I will too. So if you run into some issues, don't beat your head against the wall, okay? Same thing, show relay agent. Troubleshooting. Verify. Same thing, debugging. And then the summary. And you can look at this. I mean, go back through. I'm going to add a picture here. So why don't you go ahead? Are there any questions on the lab right now? Why don't you go ahead, go back and work on the lab a little bit. I'm going to add a picture of the lab to this. Okay. All right. So think about this a little bit. You created these, right? You created, there's 3 of them there. Maybe it's easier to see if I do that in black, right? You did something like interface, VLAN, 10, enter, and then you gave it an IP address. Okay, whatever this address is, you have a pool for that network, whatever 10 is. Let's say blue is 10. So you have a pool with those 3 major things for 10. You've excluded the default gateway, which would be this right here. You see the combination of how that all works. Any questions on that? This trunk has to be working. You have to have that trunk has to be up. Okay? And irregardless of what you do with the management, as long as you have these two configured here with the VLANs, and you have at least those two configured up here with your virtual VLANs, you turned on the routing, you have the pools, you should get an address. Your workstation should get an address. Now, for management, Samuel, your question, somewhere's in here, you might want a default gateway out if you're trying to access the management like from up here. Do you know what I mean? Where you're completely off the network and you need to get into that network. And you can configure that all the same, and you can put a port on here if you want a management device on your network. Otherwise, you should be able to get to it from any of the other networks as long as your inter-VLAN routing is working. You'll need a default here, pointing up here. And then what we're going to do to make this a little bit easier is I am going to substitute a router in here, and we'll use a different addressing. Okay? And then eventually that router will be connected to all of your configurations. Okay? And I'm going to have you do OSPF between them. Get it? So you'll have to configure OSPF. So I will set that up after we get done today, and then you could experiment with that over the weekend if you have time. But so right now we're going to connect here, and I'll set that up, and I'm going to set up DHCP in this router so we don't have to worry about any of this other stuff right now. Any questions on your configuration right now that you're working on? All right, super.